Nikki, and today's video is on balancing redox reactions.
So balancing oxidation reduction reactions is best approached from the perspective of half reactions. Here's a process. First, get the oxidation numbers in the overall reaction. Separate the half reactions. Balance the half reaction using the techniques we know already. Then multiply the half reactions as necessary to balance electrons gained by one reaction and lost by the other. Finally, combine the half reactions, cancel, neutralize H+ ions, and check at the end. Here's an example in acidic solution. First, we'll get the oxidation numbers, and notice that the silver here has been oxidized with a +1. Nitrogen has been reduced. It's got a -3 change to its oxidation number. So our first reaction will be the reaction here with the silver, as the silver goes from silver metal to silver ion and loses 1 electron. The reduction reaction will be the nitrate. Here, make sure you balance everything. You'll need 3 of the oxidation reactions, so that the 3 electrons lost by the silver are equivalent to the 3 electrons gained by the nitrate. If we add up all these reactions, or these two reactions together, and check in fact that they balance, you can see this technique. Here's another example. We'll just do all the oxidation numbers first, and see that zinc was oxidized. Its oxidation number went up by +2, and nitrogen in this went down by -8. So the oxidation reaction here will show the zinc losing 2 electrons, becoming zinc 2+ ion, and the reduction reaction, of course, has the nitrate in it, and the ammonium ion. We'll also add some water here to balance the oxygens, hydrogens to balance the hydrogen, and so on. We'll need 4 of the first reaction so that those 8 electrons that it releases will be equal to the 8 electrons gained in the second reaction. Add the 2 reactions up down here at the bottom, and be sure that they do in fact balance. Here's a third example, this dichromate ion here. We'll quickly write down all the oxidation numbers for the various constituents. Let's just get all these in here. Write down the oxidation numbers. And we'll see that in this case, the carbon has gained, it's increased its oxidation number by 1, so lost an electron. And the chromium has decreased its oxidation number here and been reduced. So let's have a look at the oxidation reaction. Here we have the ethanol being oxidized here to acetic acid and releasing 2 electrons doing it. In the reduction reaction, we have the dichromate ion, of course, and the chromium 3+ ion. We'll have to just do a bulk balance on the chromium, fix the oxygens and hydrogens like this, and we'll see that 6 electrons are required. We'll need 3 of the first reaction so that it's 6 electrons balanced as 6 electrons consumed by the second reaction. Add both reactions together. We'll just do this, make sure we have everything working here. You're going to find at the end, get a little bit careful because we see water on both sides here and hydride ions. So we'll just make a net version of this reaction at the end here by looking at what goes in and what comes out. 7 waters and 3 waters, so we can just have 4 waters on the right hand side here. And also looking at the hydride ions, 14 and 6, we'll remove the 6 and have 8 on the left. Therefore, if we go ahead and write the whole reaction, you get this one here as shown after reduce the components as shown above, so that we have just a net ionic equation that's left at the end. Okay, so there's the situation. Here's our 4th example and last example, I think, for today. In this scenario here, we'll just go ahead and write all of the oxidation numbers. Chromium here has an oxidation number of +6, and in the phosphoric acid we have +1, +5, and -2, and of course +3 on the chromium 3+ ion. The change for phosphorus here was +4, so it's oxidized, losing 4 electrons, and the chromium was reduced here, gaining 3 electrons. So the oxidation number here, the oxidation reaction, I do apologize, we'll just quickly balance that one up using water to balance the oxygens and using hydride ions to balance the hydrogen and electrons to balance the charge. The reduction reaction is done in a similar manner. We have the dichromate ion and being reduced down to chromate 3+ ion. We'll add the water, H+ and electrons here to balance oxygen, hydrogen, and charges respectively. So these reactions will need to be multiplied by 3 and 2 respectively, so that a 12 electron balance is achieved. And if we go ahead and write that down, we wind up with the reaction as shown here. There will be some reducing or will be some reduction of, not in the sense of oxidation reduction, but we'll have to reduce some of the constituents on the in and way out here so we have a net reaction. Let's do that now and see if we see there's 6 waters on the left, 14 on the right. So we'll remove the 6, that'll give us 8 on the right. And of course, looking closely here at the 28 hydrogens and the 12 hydrogens, we'll remove the 12 and have 16 on the left. If we do that, we'll get the net reaction as this one here, and just making sure that we get all the charges in there correctly and be sure that everything is matching up. The idea, of course, being that the electrons gained by one reaction are equivalent to those lost by the other. That's the half reactions technique. We'll do a mini video on basic solutions later. Thanks everyone, have fun! Do have a look at the next 2 videos for more, and stay tuned for our next lesson, lesson number 28, Spontaneity of Redox Reactions.
This is my dad's YouTube channel. It's awesome. So like, comment, and subscribe!